Ya, Assalamualaikum warahmatullahi wabarakatuh dan selamat petang. Saya daripada grup Expert Group 1 akan membentangkan tajuk soil sampling. Okay, soil sampling ni dia boleh dibagi pada dua. First, unlisted sample soil and listed sample soil. Sample soil ni dia macam cara kita dapatkan tanah tu sebelum kita buat ujian kat dia. Okay, first, for listed soil sample, is soil that has been changed from its natural condition by excavation or other means. In which care is taken to ensure that at least the composition of the soil remains unaltered, obtained by more rugged but relatively crude, and can be used to determine mineralogy, tensile distribution, liquid limit, and plastic limit. Factors that affect sample disturbance: first is area ratio, second is clearance, and last is cutting edge taper angle. And for unlisted soil sample, is soil at any depth that has not been excavated or disturbed by excavation or construction, in which care is taken to cause minimal disturbance to the density, structure, and water content of the soil. Obtained by carefully designed samples, can be tested in the lab to determine both the physical and engineering properties. The factor that influence the quality of unlisted soil sample: first is volume displacement, set friction, lateral expansion, variation in water content, hydrostatic pressure, environmental condition, and the last is handling and transportation. Okay. Disturb ni dia macam tanah yang kita ambil tapi dia macam terganggu dia punya soil structure, sifat kimia dia, fizikal dia. Yang disturb ni macam tak terganggu lah, dia macam natural tanah lah kita. Okay, differentiate between disturbed and undisturbed soil sample. First is disturbed sample change in the stress condition, but undisturbed sample no change due to disturbance of the soil structure. And second is change in the water content and water ratio, but undisturbed sample no change in wet ratio and water content. Disturbed sample disturbance of the soil structure, but for undisturbed sample is no change in constituent and chemical properties. And the last disturbed sample have chemical change and missing isolation of soil constituent. But for undisturbed sample, no disturbance of the soil structure. Okay. Lepas tu type of sample ni adalah cara untuk kita dapatkan. For disturbed sample dia ada tiga. First is split barrier sample, kedua is continuous auger, and last is bulk sample. For undisturbed sample is thin wall Selby sample, distance sample, and drop sample. Okay, first for split barrier sample ni, used to obtain disturbed sample in all type of soil. Typically used in conjunction with the standard penetration test. The test provide an indication of the relative density of the granular deposit and its approximate shear strength. Used for cohesive soil to determine its unconfined conformity strength. Available in standard length of 457 mm and 610 mm. Okay, split barrier sample ni dia yang silinder ni kan. Dia cucuk, dia letak atas tanah. Lepas tu ada macam jentera, dia tolak benda tanah. And then dia akan angkat balik, so sampel tanah tu akan terkumpul dalam silinder tu yang gambar kat tepi ni. Itu cara dia lah. Yang kedua ialah continuous auger. Soil auger and sample are used in forestry, environmental and agriculture application. Used for obtaining sample at or near the surface. It is recommended to use a power auger for depth greater than 1.5 meter. Augers are used to bore to a depth where a sample is to be obtained using a soil sample or core sample. Using dirty and rusted equipment will affect your result. Always clean your equipment after each use to prevent cross-contamination and rusting. Okay, konsep auger ni dia lebih kurang macam tadi, tapi dia macam bentuk gerudi sikit. So dia akan pusing masuk dalam tanah sampai dalam, and then dia akan tarik balik. So sampel tanah ni akan terkumpul dekat celah-celah. Yang ni dia boleh merosakkan struktur tanah lah. Itu dia masuk dalam kategori disturbed sample lah. And the last bulk sample. These are disturbed sample obtained from auger cutting or test pit. The quantity of the sample depends on the type of testing to be performed, but can reach up to 25 kg or more. Testing performed on the sample include classification, moisture density, lime rock, bearing ratio, and porosity test. The portion of each sample should be placed in a scale container for moisture content determination. And for undisturbed sample, first is thin wall Selby sample. Selby tube is thin wallet tube with one end that as a cutting edge and another that as the attachment required for the sample heat. Selby tube used for collection of intake and mostly undisturbed sample of fine grade soil like clay or sand. The diameter of the Selby tube is 3 cm or 4 cm and long is 30 cm. Selby tube can be made of steel, stainless steel, galvanized steel or brass. Thin wall Shelby sample ni dia sama dengan yang ni, split bearer sample. Tapi beza dia cuma Shelby tube ni dalam silinder ada silinder lagi. Macam gambar bawah ni. Sebab nanti bila tanah tu masuk, dia takkan rosak lah sebab dia masuk dalam silinder yang kedua ni. So itulah dia masuk unlisted sample. Okay, method of thin wall Shelby sample. The tube must be attached to a string or the rod and lowered into the borehole. The sample is placed into the unlisted soil by hydraulic force. Macam dalam gambar ni, nombor 4 ni. And then the tube is then brought back to the surface where the tube contain the sample is removed from the sample heap. Kemudian dia akan tarik balik ke atas. Lepas tu kita akan buka dia untuk dapatkan sampel tanah ni dalam gambar. And second is pistol sampler. Although it can be used in stiff soil, it is useful for conditions of soil before sample recovery in this station is normally challenging. The pistol sample is basically a thin wall tube, sample with a piston rod and a modified sample head. Yang pistol sampler ni dia lebih kurang macam Shelby tu, tapi cuma dia sesuai untuk tanah lembut. Sebab kat tengah dia ni ada actuator rod ni, dia untuk senangkan lagi lah nak tarik tanah lembut tu. Tapi proses dia sama je macam Shelby tube tadi tu. And ni dia punya prosedur dia, lebih kurang je. Cuma cara dia lain sikit. Okay, and the last block sampler. Block sampler have not traditionally been available for testing from the deposit of clay. The past decade there has been increasing use of rotary recording method to obtain such sample, and they are capable of processing very good quality samples. During the sampling process, there is stress relief and the block of soil will experience zero total stress. It will lead to less reduction in the pressure in the block, with only it will reduce the effective stress in the block. It is an excellent method of ensuring the soil remain unaffected by shear distortion during sampling. This method may not have the same effective stress as those in the ground. Therefore, the strength and porosity will differ. Okay, block sample ni dia punya method, cara dia first, dia akan gali macam bentuk petak macam A ni. Lepas tu dia akan buat macam ruang bawah ni. Kemudian kita akan tambah 2 layer, iaitu cheese close and warm wax. Macam dalam gambar besar ni. Kemudian dia akan potong bahagian bawah. And then kita akan letak dia dalam wooden box yang ada ruang sikit. Untuk tak kacau dia punya struktur tanah lah. Lepas tu yang soil sample soil ni kita hantar ke lab untuk dikaji. So itu sahaja from expert group 1. Thank you. Next, Yasin. Sin. Hello.
Okay, next chapter is rotary wash drilling machine. Okay, next chapter is rotary wash drilling machine. Next slide. There are 4 content in this slide, which is introduction, type, procedure, and advantage. The first thing I want to explain is about background of rotary wash drilling. Rotary wash drilling is one of the method borehole drilling to observe the condition, characteristic, and quality of soil, specifically to check the mineral contained in the soil. The drilling executes the challenging part in drilling borehole, where there are various kinds of soil and rocks. So to ensure the formation of soil sample can be taken nicely, the drilling machine use high frequency and speed of rotation. Generally, diamond bits are used in rotary drilling. However, in some circumstances, tungsten carbide bits are utilized, which are appropriate for drilling through rocks. Rotary drilling can typically reach depths of up to 100 meters underground and generally drill boreholes with a diameter of 50 millimeter to 200 millimeter. This is a sample of diamond bits and tungsten carbide bits. Next is the types of rotary wash drilling. There are two types. The first one is open hole drilling, where the oil reservoir is completely exposed during completion of a straight or horizontal well. Soils and basically this open hole drilling is for soils and weak rocks condition. Then the other one is core drilling. Core drilling employs a hollow punch or drill bit to remove a clean core. And this is usually for hard rocks and hard clays. The procedure of rotary wash drilling machine is the first step is in the rotary method. The hole is drilled by a rotating bit to which a downward force is applied. Then the bit is fastened to and rotated by a drill string composed of high quality drill pipe and drill collars, with new sections or joints being added as drilling progress. Then the cuttings are lifted from the hole by the drilling fluid, which is continuously circulated down the inside of the drill, string through water courses and nozzles in the bit, and upward in the annular space between the drill pipe and the borehole. At the surface, the returning fluid mud, which is mud, is diverted through a series of tanks or pits which afford a sufficient quiescent period to allow cutting separation and any necessary treating. In the last of these pits, the mud is picked up by the pump suction and repeats the cycle. So that was basically the step of rotary wash drilling machine. And this is the sample of video. Drilling is rotating and driven into the surface. So that is the animation of rotary wash drilling machine. And what we can say about rotary drilling machine is the advantage of it is the strength. Rotary methods can effectively in both hard and soft lithology, which is the condition of soil itself. And next is flexibility, easy to set up and have the ability to be transported. Large diameter, capable of large diameter boreholes, rotary can achieve deeper depth. And last is speed. Rotary drilling is a fast method. It also delivers high integrity results of the sample. So for that, we can know the availability, characteristic, and quality of soil based on the rotary wash drilling machine method. Alright, that's all for me. Thank you.
Nampak slide tak?
Boleh nampak.
Nampak.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. We are from Group 3, want to present about standard penetration test. And these are our group member and the example picture of standard penetration test. Standard penetration test is an in situ test and used to determine the subsurface soil, especially for cohesionless soil, and it carried out in borehole and measure the resistance of soil strata to the penetration undergone. And it determined the relative density, angle of shearing resistance of cohesionless soil, and the unconfined compressive strength of cohesive soil. Relative density means the measurement of compactness of cohesionless soil, and angle of shearing resistance means it taken from the slope of the line, and unconfined compressive strength is the maximum compressive stress that can be under zero confining stress. And cohesionless soil is soil strength that depends on friction between particles, for example, sand and gravel. And cohesive soil is fine-grained soil that are easily deformable soil, like clay. The instrument that used in this test is first drilling equipment, as you can see in the first picture. Second is split spoon sampler, drop hammer, driving head, and the last one is guiding rod. The procedure for this test is a 51mm split spoon sampler is driven into the bottom of the borehole. Using a 64kg hammer dropped from 760mm height, the number of blows is counted to drive the tube to 75mm deep. The test is repeated up to 6 times to achieve 450mm deep. The correction in standard penetration test. Before SPT values are taken, the N values have to be corrected. There are two corrections, which are diathesis correction is used for granular soil and overburden pressure correction for saturated fine sand and silt. The first one is diathesis correction. This formula is used when it has the presence of fine sand and silt and the water table is at or above the test level. In this formula, the N1 value is to take bigger than 15. These are the formula. Next is overburden pressure correction. It need to be used when it has the presence of questionless or granular soil. Effective overburden pressure, or we call as confining pressure, affected by depth. When the depth is increased, the confining pressure also increased. So the SPT value is overestimated. When the depth is decreased, the confining pressure also decreased. So the SPT value is underestimated. So this is the formula for overburden pressure correction. Next.
So I will continue the presentation. So there are a few factors that affecting the N values. The first one is the attitude of the operators. It may, depending on who is operating the rig, so some rig can vary because maybe the mood of the operator and time of drilling. The next one is overdrive sampler. The higher blow counts usually result from overdriven sampler. Third one is drilling method. It may vary because there are a few drilling technique. There are case holes and much stabilized holes. And the last one is not recording blow counts and penetration accurately. Next. Next. Okay. There are correlation between SPT and soil properties. So when the SPTN value is between 0 until 4, the relative density is very loose. And then when it reaches 4 until 10, it becomes loose. 10 until 30, medium. 30 until 50, dense. And above 50, it's very dense. Next. And then there is unconfined compressive strength of cohesive soil. So when the SPT N value is below 2, it's considered as very soft, and the Q is also below 25, it counts as very soft. And when it, you can always refer back to the table. Next. So there are a few advantages using the SPT. So the first one is the test is quick, simple, and economical. Next one is it provides a representative soil sample, such as visual inspection, classification test, and for moisture content. The next one is able to penetrate dense layers, gravel, and fill. And also it provides useful index of relative strength and compressibility of the soil. Next. There are also disadvantages of using the SPT methods. So the result will vary due to any mechanical or operator, as I told you earlier. And then the test is costly and time consuming. The sample retrieved for testing is distributed, and the test results from SPT cannot be reproduced. And also the application of SPT in gravels, cobbles, and cohesive soil are limited. So we have some precaution during the test. So split spoon sample must be in a good condition. Then second one is the cutting shoe must be free from wear and tear. Third one is the height of fall must be 750 millimeter. Any changes from this will affect the N value. And then the drill rods used must be in standard condition, and bend drill rods are not used. And before conducting the test, the bottom of the borehole must be clean. Maybe that's all from expert group 3. Thank you.
Can you see my slide?
Can.
Okay, I am Muhammad Syed Ashraf. as a representative to present for standard penetration test for correlations, which mean correlation between SPT and value and different parameter of soil. So what is SPT? As a previous presenter already told you, SPT used to correlate different soil parameters, and SPT can also estimate the bearing capacity of foundation and the stress strain modulus. Stress strain modulus. this this is exactly my part, which is a correlation between SPT and value and different parameter of soil. Okay, the Zani impact give the following correlation with two type of soil between SPT value and other soil parameters, which is cohesion. For cohesionless soil, we refer to this table, and then for cohesive soil, we refer to this table. So what exactly cohesionless soil and cohesive soil? Cohesive soil is a fine-grained soil, and which means low strength and can be moved. For cohesionless soil, it any free running type of soil such as sand and gravel, and strength depend on friction between particles. And then we go to this slide. Okay, correlation with unconfined cohesive strength of soil, cohesive soil in equation 1.1, which is modified from the Zani impact relationship, which is from this table. From this table, from this O and this O, we create equation for unconfined cohesive strength, and while correlation with angle of interpretation of cohesionless soil in equation 1.2 was originally in a graphical representation by PEC, which means by this representation we get these equations. And then we go next. And then from this, we can see the N16 and N116. How to get that? We use this formula to get this, which means N16 represent the corrected SPTN value for field procedure, and EH represent the hammer of efficiency, which is we need to refer the table, and CB borehole diameter correction, also we need to refer the table, and sampler correction also we refer the table, or line correction we also refer the table. And then N major SPTN value is data. And then this is correction of SPT value for overburden pressure. Okay, how to get CN? We use the formula or this formula, which is there are two researchers that doing the research, and they get different type of overburden pressure correction factor, but you can use either one. So what is the symbol? The symbol is effective overburden pressure. And then this, until this, we will refer the table 1.1. Okay, this is table 1.1, which is to get this value, we need to refer this table. This table is will show you the hammer type, how the hammer type is working, and the diameter of the hole, and also sampler correction, either standard sample or standard without cleaner. And then we get the rod length correction. Rod length correction we have familiar. I will show that to you. Okay. And then this is correlation of n value. Correlation of n value, unconfined cohesive strength, and angle of interpretation by other researcher, which is if we know the soil type by soil classification, we can use this formula to get the to get the QU value, QU value, which means unconfined passive strength. And then this is a formula for to get formula for cohesive soil and cohesionless soil to get unit weight of soil in saturated condition, in moist condition, and in submerged conditions. Okay, this is this formula is generated by table 3, which means this table, this table, and then this this uh, this formula and this formula is also generated by this table, cohesionless soil table, and then N16 we get from the formula, N16 we get from the formula for this, and then N16 also. And then this is angle of friction for cohesionless soil. We can use, if we know the soil type by soil classification, we can use this formula to get the internal, to get angle of internal frictions. And this is some example, a basic example. And then let me read it for you. Given field and value equal to 15, depth 60 meter below ground level, soil type, find sign matrix Mika, no water table was observed within the step. Standard penetration test was performed with standard split spoon sample and hand drop donut level. Bore diameter was 100 millimeter. And then first step, we need to find the N16 value, which is we use the formula from previous slide. We need to find the corrected SPTN value for field oxygen. And this value is get from table, table 1.1. And then this, we need to use this formula to get the length of hole. And then we refer the table to get this value. And then this is already give. Then we get the N16 value. Okay, for step number two, soil type is cohesionless. Overburden pressure cohesion must be made. For overburden pressure cohesion, effective overburden pressure, and hence unit weight of soil must be known. Assume average unit weight of soil and value as follows. And then we use this formula to get the unit weight of soil in moist condition. And then this is total overburden pressure, and then this is effective overburden pressure. And then after that, we need to find the cohesion at SPT value for overburden pressure, which is we have no water table is observed at 6 meter. If yes, we need to refer the previous formula, and we use the formula to get the N116 value. And then if since soil is not under water table and N16 less than 15, hence no need for differentiation correction. Just take the value from this. If underwater, use correction of SPT value for water table. That's all for me. If there are any question, you can ask. If not, you can proceed. Thank you.
Hello and good evening to everyone. Boleh nampak slide tak?
Boleh.
Alright, thank you for responding. I will continue the presentation with the topic of correction on SPT and number N60. And I am from expert group 5. This is our group expertise. So correction on SPT and number N60. The SPT and number obtained need to be corrected, normally based on 60% energy transferred to the sampler due to first is the depth of the sampling, and the second one, length of the rod, third, size of the borehole, and last one is the type of efficiency of the hammer used. Next, correction for field procedure, energy correction are always appropriate. Overburden pressure correction may or may not be appropriate depending on the procedures. For cohesive soils, there is no need for overburden pressure correction is made. Then it is fine sand or silt underwater table with N value greater than 15. The dilatancy correction is made. For coarse sand, dilatancy correction is not required. All right. So on the basis of field observation, we need to standardize the field SPT number as a function of the input driving energy. The variation in testing procedures may be at least partially compensated by converting the measured N to N60 as follow. This is the given equation, whereby the variable in this formula is as in this area. For the value of EH, CB, CS, CR, and N, CR can be referred to the table 1.1. Table 1.1 is here, same just like our previous presenter. So the factors shown are normally applied. However, those factors may vary depending upon the availability. Correction may be made with respect to overburden and expressed as suggested by Whitman. So this is the table, same like Shahid has explained. So this is all from me. Thank you.
Okay, Assalamualaikum. Selamat petang. Boleh dengar ke?
Boleh.
Okay, kita start. I'm from expert group 6, and we are to present Macintosh JKR probes. Here is where our presentation begins with our expert team. Next, table of content, introduction, equipment, procedure, comparison, and conclusion. First, introduction, definition, and objective. Definition: the JKR probe is a simple site investigation procedure that is relatively inexpensive. The probe is often used in Malaysia, especially for preliminary site investigation to assess the subsoil layer and the bearing capacity of soil. There are 3 objectives for this type of probe. collecting a distributed soil sample for grain size analysis and soil classification. And the second one is determine the subsurface stratigraphy and identify materials present. And the last one is evaluate soil density and in situ stress condition. Yang mana kita akan ketuk rod to determine all this type of information. So we move on to equipment and procedure. The apparatus for Macintosh or JKR probe test. The first one is coupling. Coupling is a connector for the rod, and then rod penetration, cone, wrench, which is pipe wrench, and lifting device, plus hammer and body cap, and nut. So we move on to procedure Macintosh JKR probe test. First one, we have to raise the hammer to its maximum height and release it freely. And then we apply grease to rod coupling. After that, remove the hammer attach the rod coupling to the pretest penetration rod. And set another penetration rod to the coupling. Then we reinstall the hammer nut and cap to continue the process. Then continue hammering process until soil has reached the set condition. When the test is done, we use the wrench, which is pipe 1, to remove the rod and coupling. After all that, the data obtained, we tabulate it in the form and plot the graph. So this is the precaution because we typically use this type of test manually. So human error cannot be avoided. So there are some precautionary measures to prevent errors in testing. This one, the drop of hammer should be a free fall and consistent drop height. And then components and apparatus properly washed and oiled. This is because we do not want the component inside penetrating rod to be damaged and keep it assembly. So this is the video for the how to operate Macintosh Pro and JKR. So that's all. So we proceed to comparison.
Hi, my name is Fatima. I will continue the presentation. For comparison, difference between JKR and Macintosh probe and their outcome. Okay. JKR probe and Macintosh probe is the same thing, but it's slightly different for angle of curve. So for JKR probe, angle of cone is 60 degrees, while Macintosh probe angle of cone is 30 degrees, as you can see in the slide. Okay, next. So this comparison between Macintosh, JKR probe, and SPT. So SPT, this test is the most popular, and economical means to obtain subsurface information. So as in the table, so for Macintosh probe, so the cone angle, as I mentioned before, is 30 degrees. For JKR probe and SPT is the same, which is 60 degrees. So for the weight of hammer, Macintosh for 0.5 kilo, for JKR 5 kilo, and for SPT is 63.5. For the height of fall, Macintosh is 300, JKR for 280, and SPT 760. For diameter of rod, for Macintosh 30, for JKR probe 12, and for SPT, standard outside 50.8 millimeter and inside 33.8. So next. This relationship between SPT, JKR probe, and unconfined compressive strength of tape. Okay. The blow count for the next to 100 millimeter, the final 300 millimeter penetration increment is used as the penetration count, and unless the last increment cannot be completed. So either from encountering rock or the count exceeding 50. So next. So this is the relationship between SPT, probe, and allowable soil pressure of sand. So over 50, relative density is very dense. For allowable soil pressure is 470. For JKR or Macintosh probe, it's 110. So next. So conclusion. As a conclusion, probe Macintosh or JKR is very useful in the site investigation to measure the suitability of soil for the construction work. The advantages of using this method is may reduce the testing cost, easy to do, and then it reduces the number of boreholes required, and speed of operation. So that's all from our group. Thank you.
Hello. Nampak tak?
Nampak.
Okay. Assalamualaikum and good evening everyone. My name is Munir binti Muhammad Zain, and today I'm gonna talk about vein shear test. So I'm from group expert group 7. This is our group member. So the definitions of vein shear test is the process of calculating the undrained strands of fully saturated soil or clay without any disturbance, and it is a very quick and easy test to perform, and it mostly preferred to calculate the shear strands of soil, and it can be done either in the site or in laboratory. It is basically used in soft soil because in hard soil it is a bit difficult to apply torque by the machine route to get the exact value of strands of soil. So this is the equipment that we use to do this test, which is vein shear apparatus. In this one, we use inside, and this one we use in laboratory. So the second one is container for specimen. It's only used when we do in laboratory tests. And the last one is vernier calipers. And the procedure for this test is first we need to clean the apparatus. Then we need to grease the lead screw for better movement of handle. Second one is when the soil specimen is taken from container that is generally 75 millimeter in height and 37.5 millimeter in diameter. So the soil surface, the top of the soil surface is level, and then the container is mounted on the base of the vein shear test apparatus using screw. Then the vein is lowered gradually into the soil specimens until the top of the vein is at depth of 10 to 20 millimeter below the top of the soil specimen. So after that, we can read the initial reading of pointer on circular graduated scale. And then the sixth one is the vein inside the soil specimen is rotated using torque, applying handling at the rate of 0.1 per second. Lastly, the final reading is recorded when the specimens fail where the strain indicator pointer will move backward on the circular graduated scale. 8 is the angle of the torque is can be read when we read the difference between initial and final. The 9 is the procedure is repeated with two more soil specimens and average shear strength is calculated. So lastly, we use the vernier calipers to measure the diameter and height of the vein. So this is the formula when to determine the shear strength in vein shear test. So, and this is the example of the calculation. If we get the value from the test, and then the advantages of this test is it is flexible because it can be performed either in laboratory or in the field directly on the ground. And B is the vein shear test is relatively quick and easy. And C, even the shear strengths of soft clay are greater deep can be obtained by using this test. So these advantages of this test is cannot be conducted on the fisher specimens of clay. B is vein shear test is also not desirable for the clay specimens with a high sense of self-lamination. C, the vein shear test does not give an accurate result if the failure envelope is not horizontal. So that's all from me. Thank you.
Assalamualaikum. My name is Nepaki Bizgifli. I will share with you guys about cone penetration test or CPT. CPT is an in situ test that is used to identify the soil type. In this test, a cone penetrometer is pushed into the ground at a standard rate which is 20 millimeter per second, with a regular intervals during penetration. The cone penetrometer is instrumented to measure penetration resistance at the tip and friction in the shaft. During the test, it is conducted in the form of a 20-ton truck or smaller vehicles, depending on the site condition. The advantages of CPT is fast and continuous profiling, repeatable data, economical and productive, strong theoretical basis for interpretation. And during the test, we'll come up with 3 measurements, which are QC, measured cone resistance, FS, stiff friction, and U2 for water pressure. It's also portable, which we can move from place to place. The limitations of CPT is, although it is economical and we can use it repeatedly, it is somehow a high capital investment and skilled operators is needed. And also no soil sample during CPT and penetration resisted in gravels and cemented layers only. This is figures of what the equipment looks like. There's electric rod inside the hydraulic rams where it will give the data from the test and we can trace the pressure. After the penetration, we will come up with 3 graphs, which consists of those 3 measurements versus the depth. With these 3 graphs, we can determine the type of soil that being tested. For the procedure, I will show you a video.
Cone penetration testing is a fast, accurate subsurface exploration method. A CPT rig uses hydraulics to push a steel cone into the ground. The cone is advanced at a constant rate. The instrumented cone records continuous measurements of tip resistance, sleeve friction, and dynamic pore water pressure. The data record allows for differentiation of soil layers and interpretation of material properties. The cone stops at refusal in dense soil or rock.
Last but not least, the list of formula. After the test, we can calculate the total cone resistance, which is QT, is equal to QC plus 1 minus A net times U2. A net is a constant where it is interval between 0.35 to 0.9. Depends on the equipment we use. Then you can calculate the friction ratio. And there's 2 formulas of cone resistance, which is those 2. Then we can calculate the SU, which is equal to QC minus P naught over NK. That's all from me. Thank you.
Hello, dengar tak? Dengar?
Dengar.
Okay, Assalamualaikum and good afternoon everyone. My name is Nick Shafiq Azhan. From expert group 9, I will present about borehole shear test. The borehole shear test was developed as a method of measuring the drain's in situ shear strength of soils by performing a series of direct shear tests on the sides of a borehole. The test is intended to provide independent measurements of the drain friction angle and cohesion of soils. It is the only in situ test to give a direct measurement of these parameters in situ. The test represents a simple concept and gives results that can be directly used in geotechnical design. The mode of testing may be suited to evaluating site friction resistance of axially loaded piles and drills, shelves, or grouted anchors. The equipment is relatively rugged and portable. The test is easy to conduct and essentially operator independent and can be used in a wide range of soil. So the purpose of a borehole shear test is to sample the soil and understand its physical properties so that contract managers and engineers will know how to approach the project. So next is these three basic components from the borehole shear test apparatus. The first one is shear head. The shear head consists of a double acting pneumatic cylinder that is used to expand the shear plates outward to apply a normal force to the side of the borehole and to engage the soil for shearing. Serrated shear plates mount to on opposite sides of the shear head are used to bite into the soil, helping ensure that failure will occur within the soil and not just at the surface of the borehole. And the second one is a shear force reaction base plate. Once the normal stress has been applied and sufficient consolidation time has been allowed, the soil is filled by slowly pulling the shear head upward. This is accomplished using the shear force reaction base plate located at the ground surface and centered over the borehole. And the third one is a control console. The normal stress against the sides of the borehole is held constant during the test by pressurizing the pneumatic shear head cylinder using a regulated compressed gas applied to the shear head through the control console. Gas pressure is usually supplied by a small tank of carbon dioxide or nitrogen. The actual gas pressure applied to the shear head is registered on a pressure gauge mounted in the console and is held constant using a pressure regulator. This is the schematic of borehole shear test equipment. There are several basic components that we have mentioned, and the other thing is hydraulic gauge, worm gear, bottle glass, pressure regulator, and pulling rods. Next slide, I'll pass to Tan Yihao. Thank you.
So we go for the procedure of borehole shear test. The procedure is very simple. First, we need a form a bore at the predetermined position. So the requirement of the borehole, we need to make sure the diameter, the minimum diameter is make sure the shear head can be easily installed into the hole, and then the maximum diameter is make sure the borehole wall can be touched when the shear plate is fully expanded. After the borehole is settled, then we can install the expanded shear head into the borehole and to engage the soil along the side of the hole. Can start the borehole shear test. So the shear plate is penetrated into the soil by applying a certain magnitude of normal pressure. Once the shear head has been expanded and sufficient time for consolidation is given, the shear head is pulled upward slowly to indicate a seal failure in the soil. Then we can get the reading of shear force and normal force. Go to next slide. After we get one type of reading, we continue the test by different normal stress, and then we can get the different data about shear stress. Then we can use the normal and shear stress to do a graph, which is shown in the slide. Graph of shear stress against normal stress. Next. Okay. Then with this slide, we can continue to find the parameter of soil, because we do the borehole shear test is to determine the failure of soil, to determine the parameter. So we can use the more column strength theory to find the cohesion and friction of the soil. So from the diagram, we can see when we get the data from the borehole shear test, we can get a straight line from proportion straight line from the data, and then we can draw a mob circle from the data, and then we can get the cohesion and friction. Next. So borehole shear test is similar to diarrhea shear test, but borehole shear test is a in situ test. So we no need to carry the test in the laboratory, and then it is very straightforward and easy to install. Thank you. Thank you.
Macam mana nak?
Tekan itu slide show.
Slideshow. Check. Ni dia. Dengar suara aku. Tak dengar. Tak dengar suara aku. Okay, dengar ke?
Dengar.
Alright. Okay. I'm from expert group 10, which is pressure meter test. Okay. This is our group, expert group. Okay. For introduction. Introduction is the function of the pressure meter. Pressure meter is an in situ testing method that used to determine stress strain response that tested on soils such as hard clay, then sand and weather rock that cannot be tested with push equipment lah. Lepas tu, pressure meter testing is used to obtain strength, stiffness and in situ stress information of the ground. Okay, lepas tu the pressure meter test is performed by applying pressure to the side wall of borehole and record the corresponding deformation. Okay, next, types of pressure meter testing. Pressure meter testing has 3 types, which is borehole pressure meter testing, self-boring pressure meter testing, and cone pressure meter testing. Okay, basically borehole pressure meter testing is a common pressure meter testing lah, which is a probe insert into a reform hole known as a borehole. Okay, self-boring pressure meter testing pula probe known as self-bore insert into the ground to prevent disturbance. Next is cone pressure meter testing. Cone pressure meter testing is cone shape of probe that insert into the base of the borehole. Then it displace the soil into the cone of the probe. That will causes less disturbance to the soil to get more accurate reading. Okay, next procedure of the the pressure meter test. Okay. So basically, first we have to drill the borehole, and then the diameter of the borehole should be between 1.03 diameter probes and 1.20 diameter probes. Okay, then the probes are slowly lowered down to the required elevation using cable. And then after reach the desired elevation, the probe is fixed using clamping device. And then control unit pressure meter will open the valve which admit water into the measuring cell and gas into the gut cell respectively. Using measuring cell pressure is applied on the soil wall of borehole. The application can be done using 2 methods, which are equivalent pressure increment method and equivalent volume increment method. The volume water use of the probe volume is taken on x-axis and the pressure value obtained is taken on y-axis. Okay, if you can see the GIF here, this is the probe yang expand to the borehole of side wall of the soil macam tu lah. Lepas tu dia akan dia macam akan expand tu untuk cari pressure benda tu lah, benda soil tu. Dia expand by using masukkan water dalam tu dengan gas. Macam tu je. Okay, next. Lepas dapat reading, kita akan buat apa ni? Okay, kita akan buat graph using x-axis the change in volume of the cavity, and then y-axis pressure acting on the soil. Change in volume of the cavity ni basically is water, and then this is the pressure yang dapat daripada apa namanya ni, control benda reading tu lah. Okay, next. The method. Tadi kan dah cakap ada 2 method, which is equivalent pressure increment method dengan equivalent volume increment method. Okay, method yang pertama, dia guna after completion of time, the volume change is not. Similar the pressure increment for the next amount of time. Biasanya 1 minit is applied dan volume akan change. Volume yang change tu kita note. Okay, this process is repeated until limited pressure is reached. Okay, next, equivalent volume increment method. The probe volume is increased by 5% for the each increment. Probe volume ni which is water yang dimasukkan dalam probe tu. Gitulah. Then the probe is held constant for 30 seconds. After 30 seconds, the pressure reading is are noted, and this test can be done for every 1 meter interval between the boreholes. Okay, next, formula. Basically, pressure meter test ni ada 3 formula, which is injected volume result, limit pressure dengan pressure meter modulus, which is VL equal to V0 plus VC, which is V0 is volume required to inflate pressure meter and push soil to its original position and VC is initial volume of the measuring set. Next is limit pressure, which is PL star equal to PL minus PHO, which is PL is limit pressure and PHO initial total horizontal pressure in the ground, which is, this is the formula of PHO. And then pressure meter modulus is EPMT equal to times 1 plus Vs times V delta P over delta V, which is Vs is Poisson ratio, typically fixed 0.33. V is cavity volume during the pseudo-elastic phase equal to Vc plus Vm, and then Vo is initial or at rest volume of the measure set. Vm is equal to the mean volume of the pseudo-elastic phase ni, and delta P over delta V is a slope of the pseudo-elastic phase. Okay, next, equipment figure. Okay, as I said before, ini adalah control unit yang kita ambil reading daripada ni, and then this is the probe. Yang ni adalah expanding section yang air masuk dalam dia tu dengan gas masuk dalam dia tu, and then dia akan expand. Macam tu. Ni keseluruhan tempatnya lah, macam tu. Okay, that's all for me. Thank you.
Nampak ke?
Dapat.
Okay, today I will present about rock sampling. I'm from expert group 11. Okay, this is our group member. Okay, first, what is rock sampling? Rock sampling is the method that reveals the true potential of an area for containing a mineral deposit. Okay, rock samplers. The sample obtained from rock drilling is known as rock cores. The rock sample is the process by which the sampler, consisting of a tube which is a core barrel with the cutting bit at its lower end, cuts an annular hole in a rock mass, thereby creating a cylindrical or core of rock which is recovered in the core barrel. The function of the core barrel is to drill and retain the sample attached to the drilling rod. And lastly, the core barrel may consist of a single tube or double tube. For single tube, the sample taken is likely disturbed due to torsion, swelling, and contamination by drilling fluid. This can be avoided in hard, intact, and rocky strata. For double tube, the core is protected from circulating fluid because the inner tube of the double tube prevents washing away of the core due to the prolonged flow of water. The cutting edge coring is a bit at the end of the barrel, generally of tungsten carbide bit and diamond bit. So this is the size of core barrel and table. First, the size of core barrel is take up to 2 meter length. And second, the standard core range from about 1.25 inch to nearly 6 inch diameter. Okay, next, the method of the rock sampling is, there are two methods. There are two types of sample, which is first, rock disturb. The method of sampling is wash samples from percussion or rotary drilling. Next, the type of sample is rock undisturbed. Rock undisturbed have two methods of sampling, which is core samples and block samples. Okay, next, the quality of rock sampling. The quality of rock core encountered in boring from the barrel are influenced by drilling technique and type and size of barrel used. The length of core recovered inside the core barrel is measured of the soundness of the rock. So this is the figure of the rock sampling for a single tube. Okay, next, this two is how to calculate the rock sampling calculation using the formula of first how to calculate core recovery percent. How to calculate core recovery percent is core recovered divided by run length times 100. And then how to calculate the RQD percent is sum of all core pieces with length more than 10 centimeter divided by run length times 100 times 100. So this is the how to calculate it. So first, how to calculate the core recovery. Total length of rock recovered divide by total core run length. So the total length of recovered from the figure, add all this core calculation, core recovered, and then divide by the total core run length, which is from the bottom to the up. Okay, next, how to calculate the RQD. The total of length of sound pieces. The length of sound pieces must be more than 100 mm. So from this figure, just add on the length which is up than 100 mm. Divide, so the RQD length of sound pieces divide by total core run length, and then times by 100. Okay, next, the rock quality. So from what we calculate the RQD, we can know the rock quality. So if the RQD is less than 25, the rock quality is very poor. If the RQD 25 to 50%, the rock quality also poor. 50 to 75, the rock quality is fair. 75 to 90, the rock quality is good. And lastly, if the RQD is 90 to 100%, the rock quality is excellent. And then lastly, how to know the strength range, strength classification, and typical rock types. If the strength range is 10 to 20 MPa, the strength classification is very weak, which is the typical rock types is weathered and weakly compacted sedimentary rocks. If the strength range is 20 to 40 MPa, the strength classification is also weak, so the typical rock type is weakly cemented sedimentary rocks, schist. If the strength range 40 to 80, the strength classification is medium, so the typical rock types is competent sedimentary rock, which is some low density, coarse grain, igneous rocks. And lastly, if the strength range is 80 to 160 MPa, the strength classification of rock is strong. So the typical rock types is competent igneous rock, some metamorphic rocks, and fine grain sandstone. So this is the reference of our group. That's all for me. Thank you.
Nampak tak?
Break, nampak.
Nampak. Okay. Sekejap Okay, Assalamualaikum and good afternoon. My name is Nadina binti Muhammad Nasir and from Expert Group 2. So, topic for my expert group is groundwater table. And this is my team member, Azilmi, Faisal, and me myself. And then this is my list of content, six of it. Introduction, porosity, movement, effect, use of groundwater table, figure, and also conclusion. So for the first introduction, what is groundwater table? Groundwater table is a top level of the underground surface water where the soils or rock are saturated. The capillary fringe will located above it, and below it will be divided by the water table, which is in saturated zone. Above of the groundwater will be known as the unsaturated zone. So many people believe that water of underground river travel between the large caves and then fill it with subsurface water, but unfortunately it is a myth because the underground caves have a very uncommon amount of water. This is because the pores that come in a variety size and shapes in the rocks, so that the water will be travel between them. Besides that, the water also present in cracks, joints, and fissures along with voids between rock layers. Next is how to calculate the porosity percentage. The formula is the pore volume of rock will be divided by total volume, then multiplied by 100%. So the main elements that will be affected the porosity are the grain size and also the grain size and shape. If the size of grains peaks and have large spaces, macam gambar sebelah tu, it will have the high porosity. If the sediments has high porosity, it is unconsolidated and have uniformly sized and rounded grains, macam gambar sebelah tu lah, dia punya ni bulat-bulat. For the next picture, we can see that the grains are packed together and have small spaces, so we can conclude that the sediments become less porous. So next is groundwater movement. So as we know that water travels through the environment according water cycle. Water will run off into streams or lakes as it falls to the ground as snow or rains. So water on surface will be evaporate, then later will condense that can bring on rain or snow. Actually, surface water are linked with groundwater because the groundwater released to the surface that will become the surface water. Furthermore, surface water also can refuel the groundwater as water table. For groundwater, it is refilled by precipitation that seeps into the earth, and drinking water a drinking well, which is a circular hole that will dug all the way down the water table. So next, the effect of groundwater table. Groundwater table will disrupt the slope stability. It also will affect by decrease the soil strength. If the slope become unstable, so the building will be affected by the presence of the cracks. Other than that, groundwater can push the foundation, and this will increase in groundwater strength, which is hydrostatic pressure. The foundation is actually impossible can be lifted, but if water seeps into the basement more through widening cracks and joints, so it can penetrate the solid concrete. So the use of groundwater table is to find how to find out how deep below the surface of the water to avoid a shift in soil structure because that caused by changes in groundwater that will be unstable. Other than that, the understanding of groundwater and water level very important for groundwater resource management. And the risk that associated with high groundwater level can cause all sort of problem on any project. So how to measure water table? So the most reliable method of obtaining the depth of water table is to measure the water level in shallow well with a tape. So the surface geophysical can be used sometimes if no wells are available, but it also depends on surface accessibility for placing electric or oops. So this is the figure of groundwater table. So the conclusion, the groundwater table is a boundary between a saturated zone and saturated zone, and is the level at which water will stand in well. So the water below the water table is called groundwater, and the water table will follow the topography of the ground surface, but with more gentle gradients. So that's all from me. Thank you.
Hai, dengar tak suara?
Dengar.
Nampak skrin tak?
Nampak juga.
Okay. So hi, Assalamualaikum and good evening kawan-kawan. Saya Nur Isma, wakil dari grup 13. Hari ni nak present pasal borehole logging. Okay, kita punya content, kita ada introduction, material and equipment, procedure, how to read borehole log, logging of soil samples and logging of rock samples. Okay, introduction dia. Borehole logging ni widely used in geotechnical site investigation. Dia provide downhole access to geotechnical testing equipment, enabling the measurement and monitoring of groundwater level, pore pressures, permeability, ground movements, material strengths, and in situ stresses. Geotechnical model evolves as information becomes available, providing a basis for the geotechnical design of engineering projects. The information presented on the borehole logs, kita ada 7. Yang pertama ialah project details and dates of drilling. Kedua, borehole location details, including accurate easting, northing, and reduce level. Yang ketiga, drilling contractor and geologist details. Yang keempat, drilling methods, sampling techniques, and depth interval. Yang kelima, in situ and laboratory test methods and results. Keenam, material descriptions and boundaries. Dan yang terakhir, ketujuh, groundwater depth and reduce level. Okay, ini merupakan borehole drilling data sheet. Kalau kita nak buat prosedur borehole ni, kita kena adalah data punya kertas ni untuk kita isi dalam dia, untuk kita ambil dia punya data-data. Okay, equipment use untuk borehole log ni, kita ada plastic snap log bags, kemudian marker pens, bucket of water and water spray bottle, plastic sieve, tape measure, ruler protector, geological hammer, pocket penetrometer and hand lens. Untuk application dia, kita akan guna untuk geologic strata mapping, well inspection and construction identification, soil layer identification, fracture location mapping, and void mapping. Dia punya procedure, first kali kita akan, borehole logging should ideally be carried out in the field at the time of drilling in order to take advantage of interactions with drillers, The logging area should be well lit and ventilated and have sufficient bench or workspace for the laying out of multiple coal trays. If the logging area is fully enclosed, the facility should be equipped with a dust extraction system. How to read buku log? Kita ada 3 cara. So yang pertama, the type of soil cohesive clays or non-cohesive sands and gravels. The first method is read the material description from the table. The terms are always used with their respective soil types and never interchanged, although notes about clay or sand may be included. Another way to determine the soil type is to look at the classification in the description. Have to look at the uniform classification table to determine whether it is in the cohesive or non-cohesive division. Yang kedua, kita refer kepada water table. The extent of the watering required has a significant impact on the cost of fee watering and shoring. Usually called out in the heading as groundwater at time of drilling and groundwater at some later date. If there is no reference to water in the log, the general assumptions would be none. Okay, cara yang ketiga, kita guna consistency of soil. Determined by a blow count reading, which provides a measure of the soil density as generally measured by a standard penetrometer test. The test is performed by marking the drill string at the rig and counting the blows it takes to advance down every 6 inch. Blow count readings simply provide a scale of how hard the soil is to penetrate, and the penetration rate is different for cohesive and non-cohesive soils. The blow count is the single most important piece of information needed to determine the strength of the soil. Ini table untuk kita tengok dia punya cohesive and non-cohesive. Ini merupakan description and classification of soils for geotechnical purpose. Okay, kita teruskan kepada logging of soil samples. Logging of soil samples ni dia includes the descriptions, naming and classification of soils. Untuk description and naming, dia based on visual and tactile assessment of drill cuttings, as well as disturbed and undisturbed samples obtained from the drilling. So to avoid misrepresentation, kita kena take note 4 benda ni. Yang pertama, kita kena cross-check sample information recorded on the draft borehole log and TMR borehole drilling data sheet. Yang kedua, disturbed SPT samples should be examined and described prior to sealing in label plastic containers or bags for storage in a cool place. Yang ketiga, the ends of undisturbed tube samples should be tested with a pocket penetrometer before sealing. Dan yang terakhir, after extrusion and selection of material for laboratory testing, the remainder of the undisturbed sample should be split, examined, described, and stored in a sealed labeled plastic container. So the final soil names and USCS are determined according to the lab test result for particle size distribution and plasticity test. Untuk organization of soil data ni pula, kita akan buat dia kepada 3 row. Yang pertama, kita soil name. Soil name ni kita include dia punya minor atau major fraction and origin atau depositional environment. Okay, so row yang kedua, primary descriptors. Kita include dia punya color, moisture condition and consistency. Dan row ketiga, secondary descriptors, kita include dia punya grain size, particle shape, plasticity and condition dia. So yang dalam table yang belah kanan tu korang boleh tengok, itu dia punya ni lah, organization untuk soil dalam kalau kita nak describe benda tu. Okay, so untuk soil kita dah habis, kita move kepada rock samples. Untuk rock samples ni dia ada description, naming and classification of materials based on the characteristic of the intact rock and the discontinuities. Okay, so the description and naming, they relies upon visual and tactile assessment of core rock samples. It is best practice to inspect and describe the core samples as soon as they are sampled and boxed in natural light and in the wet condition. So to achieve this, we need to the geologist must ensure that the core is clean. A spray bottle is useful for keeping the core wet and use it while carrying out the inspection and description. For your information, the rock name should be assigned in accordance with the Australian standard and aid to the identification of rocks for engineering purposes. So kalau yang untuk macam soil tadi, kita ada 3 row, tapi kalau untuk rock, kita ada 4 row. So row yang pertama, rock name. The rock type name is recorded first in uppercase, followed in brackets by the abbreviated name for the lithological unit as published on the appropriate geological map. Row kedua, degree of weathering and primary descriptors. For highly weathered, kita guna HW. Moderately weathered, MW. Slightly weathered, SW, and fresh raw SFR. The primary descriptors will be ordered across the row in the order: color, grain size, texture, fabric, and rock strength. Row ketiga, secondary descriptors. Ni ialah secondary minerals or alterations, any minor weathering zones within a rock layer, any other distinctive bandings such as discount banding, discoloration, pervasive staining, or other notable features. Dan row keempat, discontinuity sets. Ini listed in order of prevalence down the column and described across the row in the following order: discontinuity type, angle of incidence, frequency, roughness class, aperture, infilling. So dalam tabel ni juga kita sediakan satu punya example. Row pertama apa, row kedua apa, row ketiga dan row keempat. So notes relating to discontinuities. Zones and codings must be described in terms of both composition and thickness dalam millimeter. Drilling-induced defects must be distinguished from inherent discontinuity in the rock mass. Hill defects and other lineaments or anisotropic fabrics within a solid unbroken rock mass must be described as such. Note that the discontinuity persistence can only be measured in the field. Jadi itu sahaja daripada tentang buku logging. Terima kasih.
Hello, boleh dengar tak?
Boleh.
Okay, Assalamualaikum and good evening. So, I'm from expert group 14. So, today topic is about I report. So, this is my group member, Go Jun Yu, Muhammad Izzat Haziq, and myself, Muhammad Putra. So, what is SI report? So, SI report is an important legal document that is used as the basic for design of foundation or earth structure as well as their construction. The report also forms the basis for investigating any potential instability or failure of the structure during its life. So the objective of SI report: to ensure a safe and economical design of foundation, to minimize settlement and thief or any such problem during the life of the structure, to predict and adopt measures to control possible construction problems, to investigate into failures or potential failure of existing structures, to evolve an alternate design. Okay, so next. So this is the contents of SI report. So for the first one is introduction. So introduction. In this section indicates the client company and the project for which geotechnical investigation are carried out. So for the introduction, usually we put the location, name of the case investigator, and the main objectives or context of the geotechnical investigation. So for number 2 is objective of the geotechnical investigation. So this section gives the detailed objective for which the geotechnical investigations are being carried out. For number 3, details of the proposed structure. So this section gives the type and number of the proposed structure in the site, along with the extent of its area. This also specifies the nature of structure, that is whether sensitive or non-sensitive, or light or heavy. So for the number 4 is site condition. So this section gives the nature of the ground surface at the site, whether undulating or flat. If the ground is highly uneven, reference should be made to a relatively datum from which the depth to various soil strata and the sampling are measured. So number 5 is field investigation. This section report detail of field investigation, include date of commencement and completion, as well as the type of exploratory methods adopted. So for the next one is laboratory test result. This section presents the result of various laboratory tests conducted on undisturbed soil sample collected from the field. The data of collection of the samples and the data of test conduction are to be specified to indicate the time lag between the two and its possible effect on the test result. So for the next one is soil profile. So soil stratification at each borehole based on the color of the drilling fluid and soil fragments and observation of the soil sample, as well as on the analysis of field and laboratory tests, is reported in this section. For the next one is allowable bearing capacity. Using the laboratory test result, the safe bearing capacity of the soil at various depths should be computed based on the shear failure criterion as stated. So for the next one is analysis and the interpretation of result. So the result obtained from the field investigation, laboratory testing, and safe bearing capacity computation, as well as specific observation during the field investigation, are thoroughly reviewed in this section as the soil qualification based on the laboratory test and field observation. So for the next one is foundation alternative. The nature and magnitude of the load from various portions of the proposed structure, the soil profile, and the soil characteristic at different depths should be used as guidelines in working on suitable foundation alternative for the structure and in taking a judicious decision based on the strength, economy, and long-term stability consideration. So for the next one is recommendation. This is the most important section of the geotechnical investigation report, and points made here need to be clear, precise, and free from error and ambiguity. So the recommendation type of foundation for the part of the structure, the depth from the existing ground surface where the foundation is to be located. So for the next one is limitation and uncertainties of soil exploration. This section clearly specifies the limitation and uncertainties of the soil exploration due to possible inadequate budget, inadequate scope, and or objective of the soil exploration. So for the last one is annexure. All the data related to the geotechnical investigation cited in the report, as well as the supporting calculation, maps, drawing, and photograph are enclosed in the annexure in a logical sequential order with clear different number as cited in the report. So this is the example of the soil investigation report. As you can see on the left side, on the right side, there's an example of the soil profile in the report. So this is the one of the example for geotechnical engineering site investigation report that has been made by UMP. So that's all for my group. Thank you.
Okay. All 14 presentation is done. So habis lah. Thank you. Yeah.
Thank you, guys.
Thank you.
Thank you.
Great.
Thank you.
Thank you.